So just to show, I'll show you, this is now Madagascar. And what we're showing is, on the left, this is Madagascar as it is, and yellow is bad. That means there's somebody in that grid location suffering from malaria. Here's where we just do bed nets, and here's where we do bed nets plus vaccines. And what this simulation shows is that in Madagascar, just even doing bed nets plus vaccines is not enough to get an eradication. If we add another tool, the transmission blocking vaccine, then we can actually get an eradication. But it's fascinating. What you see, this is more than you ever thought you'd learn about malaria, but in the center of that island is the high part of the island, and that's where most of the people are. And so malaria up high there is seasonal. Unfortunately for them, the island is big enough that the mosquitoes thrive, and very few people live in the lowlands, and the reason is malaria. They don't want to live there. That's why most of the cities in Africa are far inland, is because of the desire to escape from malaria. So anyway, that's the example of the epidemic modeling tool. And now that we have that, it's hard to believe that in any of these diseases, tuberculosis, AIDS, polio, that we didn't have this kind of tool in the past. It makes you so much more rational in terms of what you do. And the model tells you data that you need to go and get about various things. So I think this type of advance, this type of innovation, we'll see it very broadly. You know, modeling materials, modeling alloys. You know, when you talk about batteries, you know, one of the things you need are these chemicals with great properties. Well, now we don't have predictive models for that. In the next decade, we will have predictive models for that. It's a matter of understanding both the physics and some computer science work in order to do that. When we look at crops right now, we don't have a model of what makes a crop disease resistant. But between the biology that's being discovered and the computer science, we are going to have that. And it's a phenomenal thing to have, particularly if you have changing weather conditions, to be able to see how bad is that going to be for your wheat or maize or the other crops that are more popular in Africa. And, you know, when you think about the important things in the world, you can see that computer science is going to affect those things. Hopefully in education, you know, after all, in the United States, if we don't make advances to improve the efficiency of education, then the country, because of the escalating costs, will become less educated, not more educated. In fact, we're one of very few countries who has that characteristic today, that as you get older, you are likely to be more educated. And you know, it's kind of an inversion of the time arrow. It's supposed to go the other way. Well, if we let educational costs skyrocket, we're simply not going to be able to achieve that. And there are a variety of things, but I think technology is the big promise there. You know, I'm sure some of you have played around with this website called khanacademy.org, which is Saul Khan doing nice little 12-minute lectures about a variety of things. There's many people doing work like that, but it's really an exemplar of the fact that lectures, testing your own knowledge, personalized challenge, those things should move into the mainstream, and it's very timely because we have a problem that we want to solve. And so although, you know, my full-time work is now this foundation work, I find myself, you know, coming back to people like you saying, you know, help me, give me some good computer science to solve all of these problems. And I'm optimistic that you'll deliver. Thank you. Turn the projector.
I think I'm to be the left. Well, Bill, thanks for a wonderful talk. We've got 20 minutes for your questions. What I'd like to do is, I'll take the privilege of asking the first one, but I'd like this to be student-dominated, please. There are a set of microphones, so please, if you've got questions for Bill, think of them, line up at the microphones, and please begin by letting us know your name and what your major is, and that'll be a way of introduction. I'm obviously inspired by the notion that computing has a role to play in so many of these things, and you mentioned the 7 billion threshold. I read that we're actually going to cross that threshold on Halloween, sometime on October 31st. And I wonder what you think the particular implications of population growth are on the problems that you described.
Yeah, if you go back to the 1960s and 1970s, the prediction was that world population would get up to about 20 billion. And that, from a global perspective, was very scary. And the people, the sort of liberal group at that time, Club of Rome, wrote about the need for forced sterilization and that nothing was going to work. Well, in fact, two factors avoided that. One was it turned out that as people got healthier, as they got better nutrition, they decided to have smaller families. And so today, the majority of countries in the world are actually below replacement level. Now, the peak population in the UFPA model is about 9.3 billion. I think because they underestimate what we're doing with various health things, it'll be more like 8.8, but that's not a key difference, 500 million. But the problem we have with population today is that it's in some locations that can't afford the population increase. It's exactly where we can't afford the increase. So for example, Africa, which is 800 million today, will be over 2 billion by 2040. That is, it will be bigger than China or India. And if you treat it like a country, it'll be by far the biggest in the world. And yet, in terms of stability, education, agriculture resources, that's very troublesome. So it's still very important to very quickly give women who want reproductive health tools, those tools, and to improve health, because that you have about a 10-year leg. When you get rid of malaria, just getting rid of malaria in Africa, say within 10 years, which is optimistic, it would take the peak population of Africa from 2 billion down to 1.6 billion. Just that one act alone. And so we do have levers that we can pull on this. Another lever you could pull, but people aren't very open-minded, is immigration. That is, all those shrinking countries, right across the Mediterranean, you've got all shrinking countries that should welcome those people in, but we can't count on it.